All right, so let's jump into the model now. So we got two countries, two goods, of course. Every trade model, you need to have two countries so that there's people that can trade with each other, countries that can trade with each other. You need to have two goods because if everybody's got cheese, then what am I going to give you if you give me some of your cheese? Cheese, it doesn't work. So you need to have two different goods. All right, so we're going to have a random endowment of a country specific good. Okay, so home is going to be endowed always with the home good. Foreign is always going to be endowed with the foreign good. But the trick is that the amount that they're endowed with is going to be a random variable. It's going to depend upon the state S. Okay, so S is some state of the world. We're going to assume that countries ex ante, before they know what the state is, they're symmetric, so everything is the same. The amount of endowments, the amount of labor, everything's the same. And we're going to think first about Arrow-Debreu securities. This is a little bit weird because we ultimately want to talk about equity. And equity is sort of, it's not quite as flexible as an Arrow-Debreu security. I suppose that you've probably seen Arrow-Debreu securities in other classes, even at CBS. The idea is we want contracts that depend upon the state of the world. So if our contracts can depend upon every possible state of the world, then we can fully insure ourselves against any sort of shocks. This is an abstraction from reality because in the real world, there's some things that I just can't insure myself against for various reasons. So an example might be, suppose I want to insure myself against getting a headache later tonight. I'd be willing to pay a little bit of money so that if I get a headache, then I get paid a little bit more, so it makes me indifferent to having a headache. So I'm insuring myself against headache risk. I'm not going to be able to get that insurance. Why is that? Because two reasons, right? First of all, it just doesn't exist. There's no market for it. This isn't something people typically do. And then the second, maybe more important one, which sort of hints at why there's many things you can't insure yourself against, is that it's very hard for insurance companies to actually verify that I truly have a headache. I might just be saying it because I want to get a payout. See what I mean? So that sort of asymmetric information, I have information that the insurance company doesn't have, is going to make it hard for us to do insurance. Anyway, so Arrow-Debreu securities mean that we can write contracts where I can get, the home and foreign consumers can get a different share of home and foreign goods in any state of the world, regardless of how much these endowments change. Okay, so let's look at the utility function. We're going to assume that these consumers are maximizing. So the way I've written this, we're going to use our notation that we were using last time. So this is home consumption because there's no star. So this is the utility function for home, although there would be a symmetric one for foreign with stars on it. So what we're assuming is that that consumers are going to have this CES inner bundle of home and foreign goods. S indexes the state of the world. So for every different possible state of the world, I could have a different level of consumption of the home and the foreign good. And then finally, outside of this, so here's the CES bundle, the constant elasticity of substitution bundle. Oops, I still got that straight ruler on. So that's the CES bundle. Constant elasticity of substitution bundle, which we're going to call C of S. And then outside of it, we have this 1 over 1 minus rho and then 1 minus rho. And what that does is it's going to give the utility function curvature. The CES bundle, if we double the amount of the good, we're going to double the amount of both goods. Careful. If we double the amount of both goods, then we're going to double the amount of the bundle. So in other words, it's homogeneous of degree 1. And that's not an attractive feature for utility function because we want people to have decreasing marginal utility, right? Utility functions typically we think are curved, and that's a feature we're going to recover by having this 1 minus rho up here and this 1 minus rho here. So we typically think that rho is somewhere between 0 and 1. It's going to index how risk averse people are. I say it's between 0 and 1, but I actually think we might be able to allow it to be from -1 to 1 maybe, but whatever. Okay, so anyway, that's the utility function. That's what consumers are going to try to maximize. And it's somewhat trickier than what we've done before. Well, two other things to mention. So notice, first of all, that this is a one-shot game. There's no T subscript here. So what's going to happen is there's going to be a period 1, or period 0, I should say, where people write contracts. And then there's going to be a period 1 where everything is realized. So the state of the world is realized. So what's happening is people at period 0, they're trying to sort of get the optimal amount of consumption at every period, at every realization of the state of the world. All right, so I'm going to be sort of hand wavy here. I guess it's not too hand wavy. We've gone through quite a few models that have this feature that when you use the method of Lagrangian multipliers, we're always going to get an equation that looks like this. Okay, so what this says is when we maximize this Lagrangian, well, okay, let's just write a very stark Lagrangian multiplier here. It's going to look like this. The Lagrangian function is going to be expected utility minus lambda times, say, a vector of prices times a vector of consumptions minus some sort of endowment, something like this. This is like a very stylized Lagrangian function, but it looks something like this. So if we take the derivative of L with respect to C S, one particular C, then it's going to be the derivative of EU with respect to CS. This is all very abstract. Times P is called, give it an S here too, and then set that equal to 0. And that's this is the thing that's giving us this equation here. Okay, so notice this is EU, this is an expectation, so it's an integral over all the possible states, whereas this CH here is sort of like a realized state. So if we change our consumption in one state, how's that going to affect expected utility? Okay. Lambda here is the cost of, sometimes these are called shadow prices. So lambda here is the cost of one expected util or unit of utility. Yeah, so that's all we'll say. So at some point, I think we're going to use this. We're going to set this equal to our numeraire. We can do that if we want. We can just set this equal to 1, since we get these prices, they're all relative. So we could do that. Actually, that's just something people often do. I'm not sure if we're actually going to do it, so whatever. Anyway, we have symmetric countries. So ex ante, these two countries are exactly the same. So there's no reason for them to have any difference in terms of their shadow prices. So actually their lambdas are going to be exactly equal. The lambda for the problem of the consumer in home and the lambda star for the problem of the consumer in foreign. So therefore, the solution to this problem is going to look like, it's going to have this feature. Okay, so you can see here that we could take this PHS and put it over here, right? It could be 1 divided by PHS. And then lambda would stay there. So yeah, exactly. So you can just set these two things equal because lambda is equal to lambda star. So here's the solution to the foreign consumer's problem, and here's the solution to the home firm's problem. Okay. So I say here plugging in. So if, I should probably do one of these. So basically this thing here is going to be this derivative of EU with respect to CHS. Almost, it's missing one term. And then this is going to be the derivative of EU star with respect to CHS. And then you got these two price terms. Well, since everything is symmetric, the price, well, I should be careful here. Not everything is symmetric, but we know what the price difference is going to be between these two prices. Why is that? Because we know that the price of the home good at home is actually 1 minus tau. Tau here is the trade cost times the price of the home good in foreign. Okay, why is that? Because when we ship the good to foreign, some of it falls off. Ooh, I did this wrong, didn't I? The price at home should be lower. Yeah, the price at home should be lower, right? So let's do that again. All right, I don't know why I confused myself there, but this is correct. So PH star S. So of course the price abroad of the home good is going to be higher than the price at home because there's this trade cost. So if you ship some of the good abroad, some of it falls off the ship on the way there. So in order to make sellers indifferent between selling the good at home and selling it abroad, they have to charge a higher price abroad. Okay, so how does that work? Well, check out here, we've got P star HS, and here we've got PHS. So if you replace PHS with 1 minus tau PH star S, then you can cancel out the PH stars, and the 1 minus tau ends up over here. As far as this derivative of the expected utility with respect to this CHS, you can just do it. If you just take a look here, just take the derivative of this expression with respect to CHS, you're going to see that you're going to end up with this expression there. So I'm not going to derive it, but I happened to actually, when the video was paused, I just checked there. By the way, if you kind of take a look at this expression, this is something that has to be true state by state. I'm not sure why I wrote it twice. Oh yeah, so once for the home good, and once for the foreign good, but they're very symmetric, right? So if you think about this, here we've got CHS to a negative power. Here we've got CHS star to a negative power. So it's kind of more natural if you actually put those on the other side. And what you'll see is that CHS is going to be bigger than CHS star, which just makes a lot of sense, right? So people are going to consume more of the home good than they are going to consume of the foreign good in every state at home. Why is that? Because they don't have to pay this trade cost. The price of the home good is lower, sort of all else equal. So that's kind of the intuition there. So let me pause there just to break up the discussion of the model.